Hello students, welcome to botany class. So yesterday, that means in the previous video, we have seen the monohybrid cross, otherwise the law of dominance. So law of dominance and law of the continuation of that is the law of independent assortment. And in the law of dominance and the law of segregation, both will be doing the Mendel did with the monohybrid cross. That means only one character he has taken for his experimental purpose, that is hybridization process. So whatever the phenotype and the phenotypic ratio, genotype and the genotypic ratio we got is the same one in the law of dominance and the law of segregation. That is, in the law of dominance, the phenotypes are two types. That is the tall and the dwarf. Okay, whatever may be the characters we have taken, only two categories. That is, according to the variants only we will get in the F2 generation, same kind of the phenotypic plants we can see. And the phenotypic ratio will be the 3:1. That is the total 4 plants will get in that 75% plant. That is 3/4 plants. That is 3 plants are of dominant character and only 1 plant with the homozygous recessive nature. That is 1/4 plant, otherwise 0.25 percentage. Okay, possibilities are very, very less, what we can say with this. Okay, in the law of segregation also same thing. But law of segregation, what it says, when the two different alleles are there, these two alleles never blend in the heterozygous condition, but they will show their own characters in the homozygous condition predominantly. Exactly same characters can be seen in the homozygous condition when the same alleles are present. That's the one what the Mendel said in the law of segregation. Same phenotypes, same phenotypic ratio, that is a 3:1. And how many total organisms are going to be formed in the F2 generation? Only 4. Like that only we have to say. Okay. And in the genotype also 1:2:1. And the genotypes is the capital T is to capital T, small t is to small t, small t. Genotypic ratio is 1:2:1, what we can say. Okay. But in the law of independent assortment, it's a somewhat big one and somewhat different one, what we can say. In the law of independent assortment, what Mendel says, it is a dihybrid cross. Okay, he said this is a dihybrid cross where he has taken two different characters. It is stretched for his hybridization process. So in this hybridization process, when he has taken two different characters, it is rich. These two are present on the same gene nearer to one another. That is here he has taken two characters of the same gene, same pattern. Okay, that is the seed color and the seed shape. Okay, so these two are the linked characters, what he said, but he could not explain to further more regarding this linked characters in the plant body itself for his laws to be framed. So that work was done by the further next scientist, but he has shown the path, how to do, what to do, and what could be the new things has to be done in that we have to invent, and according to the needs, that thing will be differs. So that's the one what he left out for us. So he has shown us a path to do, how to think and how to do the much more resolutions in the genetics department itself. So we are calling him as the father of genetics because of this single reason only, because he has shown us the good path. Okay, now when we are coming into the law of independent assortment, here we have taken two characters at a stretch for the hybridization. That is the yellow colored seed and the round shape are the dominant ones, and the green color is the recessive character in the seed, and the wrinkled character is the recessive character, the shape. Okay, now this has to be represented with the capital Y, capital Y, capital R, and with the small y, small r, small r. These are the parents. So in the F1 generation, what we'll get? Capital Y, capital R, small r. That is the completely heterozygous yellow round plants will get. Once we cross these two plants, this plant with the same F1 plants, then what we will expect we will get the F2 generation with 16 plants. 16 plants we will get in the F2 generation with this F1 to F1 crossing. 16 plants we will get as the offsprings in the F2 generation. So in this 16 plants, how many phenotypic characters can be expressive? 4 phenotypic characters can be expressive. That is the yellow round is to yellow wrinkled is to green round and green wrinkled. Okay, so in this, 2 characters are new according to the original parents. Those are the yellow wrinkled and green round. These 2 characters we won't see in the parental phenotypic ones, what we have taken for the hybridization process. So here, what we will get over here, what is the phenotypic ratio of the dihybrid cross? It's the 9:3:3:1. Okay, that is a total 16 plants. Check it out. Add up all these numbers, we'll get again 16. 9 plus 1, 10, 10 plus 3, 13, 13 plus 3, 16. Total 16, what we said, total 16 plants only we got. So we didn't miss any other plant. That's a cross-checking. Okay, so in this 9 plants are the yellow round phenotypic characters, and 3 plants with the yellow wrinkle, and the next 3 plants will be the green round, and the 1 plant with the green wrinkle. So green wrinkle is the completely recessive plant according to the parental phenotype of what we have seen. So least number will be the completely homozygous recessive characters, what we can see. And what is the genotype of this? Genotype will be capital Y, capital Y, capital R, capital R. That is the yellow round possibility. Then capital Y, capital Y, capital R, small r. That is the another possibility of yellow round. Then capital Y, small y, capital R, capital R. Then capital Y, small y, capital R, small r. Like this, 4 different genotypes can be expressed, can be possible with this yellow round phenotype. And the yellow wrinkled phenotype, capital Y, wrinkled is a recessive one. That is the small r, and capital Y, small r, small r. This is also yellow wrinkled. So like this, heterozygous yellow, homozygous yellow. Okay. Next one is the green round. Green is a recessive character for the yellow. That is a small y, round is capital R. That is a small y, capital R, small r is the another possible. And the last one is a small y, small r, because it's a completely recessive plant, what we are saying. Like this, the possibilities are given up for the genotype, for the phenotype of the 9:3:3:1. So in this, how many plants of with which, how many number we will get in the genotypic ratio? So the genotypic ratio is 1:2:2:4:1:1:2:1:2:1. That is the genotypic ratio of dihybrid cross. So I'm writing over here 1:2:2:4:1:2:1:2:1. Sorry. Okay, like this, we can get the genotypic ratio in the dihybrid cross. This is the genotypic ratio. When we are saying this, what is the genotype of this? So when we have seen over here, I am writing now with the black color so that you can easily identify the how many plants of this kind. Capital Y, capital R of 1 plant, and the capital Y, capital R, small r is the 2 plants will get, and capital Y, small y, capital R, 2 plants, and capital Y, small y, capital R, small r. This is the 4 plants will get. 1:2:2:4 is the 9. 9 means 4 plus 2, 6, 6 plus 2, 8, 8 plus 1, 9. 9 plants came. And here, this is the 1 plant with the small r, and two plants with the capital Y, small r, small r. And here also this is of one plant, this is of two plants, like this one plant. There is a 1:2:4:1:2:1:1. That's the one what we have written over here. Same thing we are saying. So in this, like this only, we will get the questions in the NEET exam. So what they can ask in the dihybrid ratio, what Mendel has given, in that how many are with the yellow homozygous, the yellow heterozygous and wrinkled homozygous condition. How many plants are of that kind? So two plants. 16 two plants are of this kind. That means 2/16 is the fraction. That is 1/8 simplified. 1/8 like that. And how many plants in the dihybrid genotypic ratio with the completely heterozygous condition? Complete heterozygous, capital Y, capital R, small r. These are the complete heterozygous. 4 plants are there. That's the one what we are saying over here. 4 plants means 4/16. 4/16 means it's the nothing but the 1/4. Total 1/4 the plants are of completely dihybrid heterozygous condition. So they will ask in the given plants so much number. In that, if a complete heterozygous condition, how many plants? Then we have to divide that with the 4. Okay. Then we are getting the complete heterozygous number. Okay. Right. We will see the next one in the next video. Till that, stay tuned to this channel. Right. Thank you.